Okay, good evening, everybody. Mr. Coombs here. Hope you're all well. I'm going to take you through the A-level physics course, take you through what topics that we cover. We'll take you through with the assessments, what the terminal examinations will look like in terms of their nature. We'll look at possible careers that you could go into using an A-level physics qualification. We'll have some of our Year 12 students talking to you in regards to how they're feeling that the course is going so far, and what sort of top tips they would give yourselves if you're thinking about choosing an A-level physics next year. And then we'll have a look at a demonstration to do with mechanics and the kind of the science behind that demonstration. So the topics that you got on the left hand side here, we've got 5 topics there. Now these are covered predominantly in year 12, so year 1 of the course. Measurements and their errors, particles, radiation, waves, mechanics, materials and electricity. And on the right hand side there you've got the topics that you'll cover in year 13, so the second year of the course. So further mechanics and thermal physics, so that looks at things like circular motion, simple harmonic motion, and they've got the whole thermal physics there as well in regards to gas laws. Fields and their consequences, that builds again on the stuff that you cover in year 1. So we look at electric fields, gravitational fields, magnetic fields. That's a big part of the paper 2. And then we have a look at nuclear physics as well. And in addition to that, you'll see the options. So students can take one of these options to combine with their year 13 work. So we offer astrophysics, medical physics, engineering, turning points, which is a historical context of all the physics that we've seen over the course of the years and the kind of the discoveries and inventions and so forth, and then electronics as well. So what we've got here is the assessment. So what you're going to be assessed in terms of the terminal exam. So this is what happens at the end of year 13. So in the second year of the course. Paper 1 is that says sections 1 to 5. That's essentially all the things you've seen on the left hand side of the first slide there. So all of the stuff you cover in year 1, in addition to the periodic motion. So that's the circular motion, the simple harmonic motion that I was talking about, that you do in year 2. Paper 2 is predominantly all the stuff you would cover in year 13, with the assumption that you know what you've covered in year 12. And with that, you'll have a very similar examination. So they're both worth 2 hours. And they're both worth 85 marks, and they're both worth 34% of that A level. Paper 3 is where you are assessed on practical skills. So where we looked at the measurements and the errors in that left hand side of the previous slide, that's where you're going to kind of really demonstrate your understanding of practical skills, pieces of specialized equipment, data analysis and so forth. And then in addition to that, you will also have the options, so whether that be astrophysics or engineering or medical physics or whatever option that the kind of the class has chosen. And again, that's a written exam for 2 hours, slightly less marks of 80 marks, and it makes up 32% of the A level. So that is the 3 examinations that we'll be doing at the end of year 13. The careers, I mean, there's a whole host of careers that people go into on the back of A-level physics qualification. So, you know, there's a couple of pictures there I've put on them. So we're looking at, you know, engineering. We've seen people going into the mechanics of engineering, so Formula One in particular. You've got aviation and aerospace. We've got, obviously, we've seen about the astrophysics option. It blends quite nicely into space travel and into aeronautics that way. And then, of course, you've got the nuclear physics and with research stuff. So I've put a picture up there of CERN. So, you know, the A-level physics can definitely lead to people going into the research fields. And I've also put there on the top left an aspect of law. Although you got an A-level physics and it's predominantly science, because you will be looking at very logical thinking, very analytical thinking. It does lend itself nicely to the study of law, and we've seen in my previous roles, I've seen a lot of students going into the discipline of law into university, and they've really excelled at it because they've done an A-level physics course as well. So don't just think that because you can do an A-level physics course, you're going to go, you can have to be sort of penned into the sciences. You can broaden yourself out to a more of a wider scope of careers. So now we're going to have a look at some interviews with some students in current year 12s and a demonstration that we're doing in year 1 of the course.
Hello, I'm Aaron, this is Owen. We're both year 12 students at Bedford Old Bank studying physics.
My favourite part of the A-level physics course is particle physics. We learn about what makes up the atoms and protons and neutrons and how they interact with each other.
Mine is nuclear physics because you learn about how nuclear reactors work and what's going on inside a nuclear power plant.
Some of the courses that you can study at uni after the A-level course there's theoretical physics. An example of this is string theory. If you really enjoy GCSE physics, A-level physics is very similar, just goes into more detail. So if you have a passion for it, it's definitely worth looking into.
Okay, all right then folks, so we've talked already about the course content, and we've talked to a few of the students, given their kind of top tips for you for what to expect about A-level physics next year. And we talked about, where would an A-level physics qualification lead us in terms of future careers. Now what we're going to show you here is a little bit of a demo. This is a topic that we look at in year 1, it's a mechanics topic, and we're looking at free fall. The scenario here is called the monkey and the hunter. So this is the hunter, this is his gun, all right? And over here, this represents the monkey, all right? So set the scene for you. We've got a power pack, and this is called an electromagnet. So when you put the power pack on, the electromagnetic is activated, and you've got the force of magnetism holding up this can here. So this represents the monkey. Now the monkey is a bit pesky because the hunter really wants to catch him, all right? And every time he hears the gun, he falls out of the tree instantly. So the scenario is, well, where would you aim the gun? Would you aim it above? Would you aim it below? Would you aim it smack bang in the middle? So this is ball bearing. We put that into the gun, and if you can kind of see where it's aligned currently, you can see that that is aligned almost directly towards the centre of the can. Just make sure that is exactly where we want it to be. So when the gun is released, what happens is it knocks the switch off, and this will fall exactly the same time as when the gun is fired. Okay, so again, goes back to the scenario as whenever the monkey hears the gun, he falls out of the tree. So let's just see what happens here.